Hi, and welcome to the flipped instructional session for 1.05, Measurement and Units. So just a reminder, it is important to take notes during the recording. Please make sure you title your note page with the lesson number and title. So this one is 1.05, Measurement. You can also use the unit note guides provided as well. So as we get started in the lesson introduction, it just goes over some of the tools that you'll be using in the simulations. So we're looking at what kinds of measurements can you make with them. So we're looking at recording time, mass or weight. We're looking at recording the height or the length. So for the metric ruler, we're getting, we could get the diameter of the different balls. We can also measure the height of how high they go when they are dropped. Timer is used to measure how long it takes for each ball to pass through the two gates here. The scale we're looking at can be used to get the mass. So our goals here, we want to make sure we know how to measure, record, calculate, and report results using metric units. So remember, in science, you're always going to use metric, not English units of measurement. And then we'll explain why scientists need a system of measurement. We want to talk about measuring physical quantities using the International System of Units. Identify fundamental units of the SI system and associate each unit with what it measures. Then we want to measure recorded data about physical objects, conduct measurements using the SI system, and then practice the appropriate abbreviation for units of measurement. So we have a lot going on. A lot of this will probably be review for you. You've seen measurements since elementary school. So as we get started, talking about measurement and the SI system. So how would you tell a friend your height? Would you give your height in feet and inches or in centimeters? If you are writing to a pen pal in another country, how would you express your weight? Would 1 pound be the same as the amount of weight there as it is here? Scientists face the same types of challenges in communication. They have found that to convey information accurately, they need a system of measurement that is the same around the world. This allows scientists to refer to exactly the same quantity no matter where they are. And that statement is important. You'll see that come up on the unit test. It asks about why we need one system. And so it's because we want to make sure that we're referring to the exact same quantity. So a scientist would express length in meters and the amount of material an object contains in kilograms. So if you notice, when you go to the doctor, they measure you in centimeters, and they also measure you in kilograms. So we're measuring the size of something. So if we're looking at the size of a baseball, ping pong ball, or golf ball, the diameter is usually the way that we would specify its size, but more precisely, the diameter of a sphere is the length across the sphere. So a ping pong ball and a golf ball are similar in size and diameter, but which is more likely to break a window? A golf ball is harder to stop because it has more material in it than a ping pong ball does. So the golf ball is much more likely to break the window. The property that describes the amount of material in something is its mass. So that's something you want to write down. The property that describes the amount of material in something is its mass. All right, so as we move on, we're looking at this simulation as well. So using this to practice measuring the diameter and the mass of the different balls. So which tool do you use to make your measurements? So we can practice doing this, 5.8 grams. We can see this is much heavier, 150 grams. We can see if we can drop something, it'll bounce. So lots of things we can measure, again, like the height and things like that. So what tools do we use to take measurements? So the metric ruler, we could get the diameter, and the scale, we can use that to measure the mass. Oh, this is a timer, yes. And then what's the the approximate diameter of each ball. So if you were to practice measuring that, you could look at centimeters. You can see right here the tennis ball is 10. You can move things out of the way. The golf ball is 7. You can see it's a little bit over. So you just need to practice measuring and reading those. Which ball has the greatest diameter? So you can see that the clay ball is 11 centimeters. And what is the mass of each ball? So we practice weighing those. We have 120. We know this was 150. The tennis ball was 58. The golf ball is 45. So you can see that on the scale, but it also shows it here. So which ball has the greatest mass? So if we look at the numbers, the 8 ball is 150 grams. So next it says, consider measuring the distance between two objects. So if we focus on the distance between two objects, for instance, how far apart are the planets from one another, what type of units would you use to measure distance? The distance between two objects affects how they react to each other. And you'll learn what the law of gravity. So it's a universal law. That means it's in effect all the time. And the gravitational attraction between two objects is greater when they're closer together. You may want to write that down. The objects also attract to each other more strongly when they have larger masses. So I would include both of those sentences in your notes. And then remember, you can always pause the recording to write that stuff down and then click play for it to start again. So planets are not always the same distance from one another. The distance depends on where they are in their orbit. So just as distances between planets vary over time, many other measured quantities in other systems also change with the passage of time. So what does measurement mean? We've discussed the mass of a golf ball and a ping pong ball, the distance between planets, and time in relation to change. These are all quantifiable properties because they can be expressed by a number. So if you want to write down in your notes, quantity is measured, right? Quantity is like the number. It's expressed by a number. So quantitative data, quantitative. So that's the word you're looking at. It's measured by number. Measurement allows you to determine a value precisely. But what does measuring mean? So here's another definition for you to put in your notes. It is the comparison of a quantity to a standard unit. Without the comparison to a standard unit, it is not considered measurement. All right, as we go on, we're talking about now the International System of Units, also known as SI units. So you probably know your height in feet and inches, and that is what we normally use in the US. That's a customary system of measurement. It's also called the English system. But people in most of the world use the metric system. So if you look at the map over on the right, you can see that all the countries near us use the SI system. And so if you lived in another country, you would probably measure your height in meters and centimeters. So each system of measurement has its own set of base units for different measurements. You may remember in math learning about these, and it's all based on the number 10. So in 1875, people from 17 countries agreed to use the metric system to communicate with one another. From their initial agreement, a larger system of units known as the SI was developed, and it is used in most countries. So SI units, you'll see this in your unit note guide. So this is an area where you can fill in. Currently, there are 7 base units in the SI, which are shown in this table. And so what are the base units? A base unit means you build off of that. Like a meter, you could have a kilometer, decimeter, right? That's the base is what we use. So many times the metric base unit and the SI base unit are the same. such as the meter. But sometimes the base unit is different from the metric base is different from the SI base. So you'll see that example come up too. Like for example, the base unit for temperature in the metric system is degrees Celsius, right? That's the base metric. So other countries will measure in Celsius, but the base unit for the SI system is Kelvin. So know that the SI system and the metric system, they're two different things. And in some areas they are, like in distance, you would see the meter. But in temperature, you see Kelvin in SI instead of, like in metric, you see Celsius. So make sure you know that there is a difference, and you may want to draw an additional part of your chart, and you could put there that those differences that we just talked about that are listed here. So which unit in the table would you use to measure distance in SI? So if we're looking at that, it shows you we use the meter for distance. And how would you measure mass? So you can see we use the kilogram, and time we use seconds. So anytime you're looking at something that shows time, like we did this for 75 minutes, you usually have to convert that to seconds. All right, so measuring in meters, how would you measure a tree, and how would you find out how tall it is? Maybe you want to know how big it is around the trunk, or maybe you want to find out how wide the branches and leaves stretch. All the measurements would be made using the SI unit of meters. A meter is equal to 39 inches, or just a bit longer than a yard, which is 3 feet. A person who is 6 feet tall is about 2 meters tall. So we're looking here at a picture of the Statue of Liberty. Statue of Liberty is over 300 feet tall. So how many 6 foot tall people would have to be piled on top of one another to be the same height? So you have to do a little math there to figure out if one person is 6 feet tall, then you would divide 300 feet by 6, and you would find that 50 people stacked up would be as tall as the Statue of Liberty. And then how many meters equals 300 feet? So you have to do some math there. If 6 feet is just about equal to 2 meters, then 3 feet equals about 1 meter. So if you divide 300 feet, so 300 feet equals about 100 meters. The exact height of the Statue of Liberty is 93 meters. So it's important to know how to do those conversions, and you may want to make some notes just like on these problems here so that you can remember how to do that. So next we're going into kilograms, and that's when we're talking about mass. Mass is the amount of stuff in an object. The SI unit for mass is the kilogram. So how big is a kilogram? A liter of soda has a mass of about a kilogram. Most soda bottles are 2 liters. So when you pick one of those up, you're lifting 2 kilograms. You have to be careful not to confuse mass with another measurement called volume. This is something you might want to write down. Volume is how much space an object is occupying. A full soda bottle and an empty soda bottle take up the same amount of space. So they have the same volume, but they do not have the same amount of stuff inside. So their mass would be different. When you measure light, so imagine looking at the headlights of an oncoming truck at night versus a candle light in the window. How do you measure how bright they are? The scientific term for brightness is light intensity, and it is measured in the SI unit candela. The word candela means candle in Latin, so you can remember that, candle and light. So the brightness of a candle is how the unit was defined. So the brightness of one candle. So when you compare the brightness of lights, the standard you are comparing them to is a candle. When we're measuring temperature, everyone knows fire is hot, but how hot? You measure how hot or cold places or things are by measuring their temperature. There are many ways to measure temperature. In America, we measure temperature using the Fahrenheit scale. On a hot summer day, a temperature might be 90 degrees Fahrenheit, but many countries use a scale called the Celsius scale. This scale is helpful when studying science because water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. But it turns out the SI base unit for temperature is Kelvin. So in both the Fahrenheit and Celsius scales, you can reach temperatures below zero. In fact, this frequently happens in the winter. But in Kelvin, zero means zero, and we call it absolute zero. All right, so what is the coldest temperature recorded on Earth? The lowest temperature was recorded in Antarctica, and it was minus 129 degrees Fahrenheit. So that's something we can kind of wrap our brain around. But if we convert that over to Kelvin, Kelvin is like a 273 degree difference. And so we're looking at this as the Kelvin measurement of 184. And so what's the hottest temperature we've ever seen on Earth? And that was recorded in Death Valley, California. It got to 129.2 degrees Fahrenheit. And that is 327 degrees Kelvin. All right, so now let's look at measuring electricity. One quantity you use all the time that cannot be measured in meters or kilograms is electricity. It takes a certain amount of electricity to run your computer, your refrigerator, even your cell phone. How do you measure electricity? You measure the amount of electric current that is traveling through a wire, and current has an SI unit called an ampere, or an amp for short. So as an example, most household appliances run on 20 amps. So how much current travels in a lightning bolt? It can carry as much as 30,000 amperes. So take a look at these metric prefixes, and you may want to put these in your notes if they aren't something that's very familiar. And you might have noticed that sometimes you can see centimeters instead of meters or kilograms instead of grams. And so as I mentioned earlier, the metric system uses a base 10 number system with prefixes. For example, centi comes from the Latin word meaning 100, like century. Means 100 years. So there are 100 centimeters in 1 meter. And then 1 centimeter is 0.01 of a meter. So we know a centimeter is much smaller than a meter. It's 0.01. So you can just move that decimal over. Similarly, kilo comes from the Greek word thousand. And there are 1,000 grams in a kilogram. So we know that that is bigger than a gram. There's 1,000 grams in a kilogram. All right, so recap here. You have learned to communicate clearly and accurately. All scientists have to use the same units. And these precise and standard units of measurements will be very useful tools for you. All right, so some more things you can practice. We can use this simulation to collect the following data about the ball. You can measure the mass, the bounce height, and the time. So those are things you could practice, and it gives you a little activity that you can do. Place the ball on the scale, observe the height using the ruler, and measure the time it takes to stop the bouncing ball. So just something you can practice again if you would like. All right. So we are finished with the lesson. There is nothing to submit here for grading. And I just encourage you again to join us for our flip follow-up sessions. And you can also come see me in Help Lab if you need anything extra. Have a great day.